Dear students, you are told that hydrogen is a good reducing agent. But what is a reducing agent? To understand it, you must understand what is reduction, what is oxidation. So we start with oxidation and reduction in this video. Oxidation, you know already about it a little bit. And actually the people since very long knew what is oxidation. That is combining with oxygen to form compound called oxides. And oxides are binary compounds of oxygen, means any metal or non-metal combined with oxygen, then compound is said to be oxide. So since olden days we knew that when a substance combines with oxygen, then its oxidation takes place. For example, when a fuel burns, like when carbon burns, then carbon dioxide is formed. So this is an oxidation reaction. We also know that along with this a lot of heat and light is produced. Similarly, another fuels like suppose methane burns to form carbon dioxide and water and lots of heat and light. So all the fuels burn, and in that process they combine with oxygen to form their oxides, and the process is oxidation. But oxidation is not only combining with oxygen. It is more than combining with oxygen. Let's come to know. First, which you already know, that combining with oxygen. Second criteria of oxidation is loss of hydrogen. Why combining with oxygen is similar to loss of hydrogen? Because oxygen and hydrogen are opposite in nature. Oxygen is an electronegative element. It takes electron and becomes negative radical. Hydrogen, despite being a non-metal, is electropositive element and it gains electron to become positive ion in most of the reactions. So, loss of hydrogen. How? We can see H2S plus Cl2, 2HCl plus S. In this, hydrogen sulfide lost hydrogen and became sulfur. So hydrogen sulfide is oxidized to sulfur by losing hydrogen. So oxidation is combination with oxygen, loss of hydrogen, and there is one more criteria. There are certain oxidation reactions in which neither combining with oxygen takes place nor loss of hydrogen takes place, and yet chemically it is an oxidation reaction. Such oxidation reactions can be understood and justified on the basis of loss of electron. When a substance loses electrons, then also it is said to be an oxidation reaction. I give you an example. Fe plus 2 during a chemical reaction changes to Fe plus 3. In this reaction, Fe plus 2 loses one electron to become Fe plus 3. I mean iron with 2 positive charge becomes iron with 3 positive charge. So this is an example of oxidation reaction. To elaborate, I can write full reaction like this, like FeCl2 combines with chlorine to form FeCl3. In this reaction, ferrous chloride is oxidized to ferric chloride and iron 2 is oxidized to iron 3. So there are 3 criteria for a chemical reaction or a substance to be oxidized. What are those? First, combination with oxygen. Second, loss of hydrogen. And third, loss of electron. This minus is for loss, plus is for gain, and this way learning and writing becomes easy. And what about reduction? You also know that reduction reaction also happens because we already discussed that hydrogen is a reducing agent. So what happens in reduction? It is just opposite of oxidation. See, gain of oxygen is oxidation, then loss of oxygen is reduction. Similarly, loss of hydrogen is oxidation, so gain of hydrogen is reduction. And loss of electron is oxidation, so gain of electrons is reduction. Children, this sign of plus means gain and minus means loss. Minus electron, or you can write loss of electrons. So oxidation is a reaction in which a substance or an element either combines with oxygen or loses hydrogen or loses electron. Whereas reduction is a reaction in which a substance loses oxygen or gains or combines with hydrogen or gains electron. To understand it better, let's take certain examples. Like for combining with oxygen, Mg plus O2 forms MgO. So in this reaction, magnesium combines with oxygen, therefore magnesium is oxidized. Let's come to loss of hydrogen. For loss of hydrogen, see, H2S plus Cl2 forms 2HCl plus S. In this, H2S loses hydrogen and becomes sulfur. So H2S is oxidized to sulfur by losing hydrogen. And loss of electron, see, for loss of electron, Zn plus H2SO4 gives ZnSO4 plus H2. In this reaction, zinc is oxidized to zinc sulfate. How? By loss of electron. Zn minus 2 electron becomes Zn plus 2, which is present here. Here zinc is chargeless neutral atom and here zinc is Zn plus 2 radical. So it became, how it became possible? By loss of electron. So loss of electron, that's why zinc is oxidized to Zn plus 2 or zinc sulfate. Loss of oxygen, like 2HGO on heating reduced to Hg plus O2. In this, mercuric oxide lost its oxygen. Therefore, mercuric oxide is reduced to mercury. Gain of hydrogen. Nitrogen combines with hydrogen to form ammonia. In this reaction, nitrogen is reduced to ammonia. It means it is reduction of nitrogen over here. Gain of electron. For gain of electron, let's see. Okay, we take this S2S plus Cl2 2HCl plus S. In this, look at Cl2. Chlorine means neutral atom. Two atoms of chlorine form chlorine molecule. So chlorine atom, and here in HCl, chlorine is what? A negative radical. Chlorine gains 1 electron and becomes Cl minus 1. Therefore, this is reduction of chlorine to chloride by gaining electron. Chlorine gains electron and becomes chloride. So it is gain of electron. Therefore, chlorine is reduced to hydrogen chloride. Otherwise, you can also take it like this, that chlorine gain hydrogen and due to gain of hydrogen as well, it is reduced. So due to gain of hydrogen, chlorine is reduced to chloride, hydrogen chloride, or due to gain of electron, it is reduced to hydrogen chloride. Okay. Now the question arises that does a single oxidation reaction takes place, then what happens to the electron lost or electron gained, or from where does oxygen come, where does oxygen go if it is separated? So a loss of something doesn't take during a chemical reaction according to law of conservation of matter, you already know. So nothing is really lost or gained. Loss of one is gain of another. For example, Mg plus O2 Mg. In this, magnesium loses electron to become Mg plus 2 and oxygen gains electron to become oxide. So, loss of electron by magnesium and gain of electron by oxygen. If there is no electron gainer, then magnesium all alone cannot donate electron. So, when oxidation reaction takes place, then simultaneously a reduction reaction also takes place. That's why the term redox reaction is used. What is redox reaction? When during a chemical reaction, oxidation as well as reduction reaction takes place simultaneously, which is always there. You can understand a redox reaction is a reaction in which oxidation reduction both are taking place simultaneously. Let's take one more example of redox reaction in which oxidation is also happening and reduction is also happening. Okay, take example of CuO plus H2, Cu plus H2. Now in this you see, CuO loses oxygen and becomes Cu. So this one is loss of oxygen. It means it is reduction. Whereas look at hydrogen, it becomes oxygen. It becomes water. How? By gain of oxygen. So this is oxidation. It means when a chemical reaction which apparently is only oxidation or only reduction, but it is only when you really do not go through it seriously. Otherwise, a single oxidation or single reduction reaction doesn't take place. Out of two reactants, when one is reduced, then other is oxidized. Or when one is oxidized, then other is reduced. Like in this reaction, cupric oxide loses oxygen to become copper, so it is reduced. Hydrogen gains oxygen to become water, so hydrogen is oxidized. Let's take one more reaction like this to understand that single oxidation or single reduction doesn't take place. Rather, every oxidation or reduction reaction is a redox reaction in which both oxidation and reduction takes place simultaneously. Take one more example. Fe2O3 plus CO. That is carbon monoxide. What happens? 2Fe plus 3CO2 means carbon monoxide during this reaction gets converted to carbon dioxide. Now have a look at Fe2O3 becomes Fe by loss of oxygen, that is reduction, whereas CO becomes CO2 by gain of oxygen, that is oxidation. So what is redox reaction? A reaction during which a substance is oxidized and other is reduced. Here this one is reduced and this one is oxidized. Any example of oxidation reduction, if you observe closely, then you will always find that oxidation and reduction, both the reactions are taking place simultaneously. Now here comes another term, oxidation, oxidizing and reducing agents. Let's discuss this in the next video.